Hello guys, we are back with our next lecture. In this lecture, let us continue with the third method. Okay, so let us continue with the third method of modes of data transfer, guys. So till now we have discussed programmed input output and interrupt initiated input output. So in programmed input output, CPU is working like a slave. So that is not an ideal case. Moving on to interrupt initiated input output, here there is a concept of priority. So that also we don't want. So the third method is a direct memory access, DMA, guys. So if you ask me, among the three, this is the most easy important method, and this is the method which is used nowadays. Got it? Yes. So how DMA works is, I'll be going through the example, guys. Okay. Yes. So please concentrate for some time, guys. It's really easy to understand. Or shall we go with respect to theory and let us understand? So let us first read the theoretical part, guys. Okay. Yes. So I'll be turning the page and I'll be showing you as per the requirement. Okay. Yes. Okay. So in DMA, so let me show you the diagram first. Okay. So you will have a processor. You will have DMAC, that is nothing but a DMA controller, peripheral device and address selector, and you will have RAM. Okay. Yes. So in RAM only we are going to read and write, guys. So assume that as our device. Okay. Yes. Okay. So when we want to perform IO operation, then actual source or destination is either input output device or memory. Okay. So basically here we will be controlling the input output device or the memory, guys. Okay. But CPU is placed in between just to manage and control the transfer. Okay. Hence DMA is the idea where we use a new device called DMA controller, using which CPU allows a DMA controller to take control of the system buses and perform the directed data transfer either from the device to memory or memory to the device. Okay, so I think everyone is getting some basic idea, right? Yes. So first let us see how exactly it will work, guys. I think the image cannot be seen completely in a single shot. So just give me a second, guys. I'll be increasing the height. Just give me a second. Okay, so I think now it's almost visible, right? So from the top to bottom. Okay, so we are going to have a processor, we are going to have an address selector, you are going to have DMA, peripheral device and our RAM. So here from peripheral device we want to write the data to RAM. Okay, so exactly how we will perform is, okay, so the first step is our peripheral device, means our input device will request DMA that sir please I want to send some data. So in that way it will ask, guys. So it will request a DMA to send data. Okay, so what DMA does is it is going to activate the BR signal and interrupt signal. So basically what is BR is nothing but bus request. So it is going to request for the buses from the CPU. So it is informing that to CPU. Okay, so once the CPU receives that interrupt and the bus request signal, so once its a particular task is running, so basically it is executing something, right? So once that execution is done, it will grant the signal to the DMA. Okay, so once that particular signal is received by the DMA, so indirectly now CPU is nothing but just a device, guys. So it is going to work on its own particular work, and now with the control of DMA, these address buses are completely inactive, guys, to be clear. So the above parts. Okay, so now peripheral device can directly transmit the data to the RAM. So this concept is nothing but the DMA, guys. So few students might be saying that why exactly DMA? Why not the normal traditional methods? So the main reason why DMA is used is, so here assume, let us take a small case, guys. So if you recall the previous method, there we don't have DMA. So the role of DMA was taken care by the processor. So indirectly when peripheral device is communicating with the RAM, the data used to go to the processor to the DMA. Sorry, to the RAM. So in this way the data used to go. But when the data is sending to RAM, so this is the sender and this is the receiver. Why the processor in between, guys? So with that reason only we removed that, and the processor will work on its own and the DMA will be the controller here. Okay, yes. And once that particular process is done, again you will grant the buses to the processor and processor will continue with its work. Okay, yes. So this concept is a DMA. Okay, and DMA can also work in a two different modes, guys. So the first mode is a burst mode and the second mode is a cycle steal mode. Okay, so what is a burst mode? So burst mode is nothing but when entire IO transfer is completed and the control comes back to CPU, then it is called as a burst mode. So basically DMA controller took the control of these buses and gave it to peripheral device. So once the peripheral device task is completely done, and at that time if it return, so it is indirectly using burst mode. Okay, when it comes to cycle steal mode, okay, so when a CPU executes an instruction, there are normally 5 different phases, guys. Please start understanding or start remembering these phase names, guys. So the first phase is instruction fetch. Okay, so here you are going to fetch for that particular instruction. Means you need to have access to the memory, right? So indirectly it is going to fetch from somewhere. Okay, similarly ID, which is instruction decode. So if you want to decode something, do you need the use of memory, guys? I think no need, right? Yes. Similarly operand fetch, so you are going to search for your operands. So here also there is no need, here also we need the memory. Okay, similarly moving on to IX, that is nothing but instruction execution. So when execution is going on, the execution will go on in processor, right? Yes. So hence here also there is no need of memory. Similarly write back, so you are going to write back to the memory, so there you need memory. So here ID and IX, instruction decode and instruction execute phases, CPU does not require system buses, and if only in that time control is given to DMA, it is called as cycle steal. So in one instruction you are going to give, you are having 5 different stages in which 2 stages are not using the system buses. So at that time if you give in this 2 units of time, each and every time if you are giving for DMA to transfer some data from peripheral device to RAM, so that concept is called as a cycle steal, because you are stealing some cycles from the process which the CPU is doing, right? Yes. So this concept is all about DMA, guys. Okay, so there are various questions with respect to DMA, guys, and this is an important topic. So the questions and all those things we'll be discussing along with PYQPs, guys. Okay, yes, in PYQP series you can watch the questions. Okay, yes. So I hope everyone got a clear idea with this with respect to DMA and all those things. So in the next lecture, let us discuss about mass storage structure. That is nothing but we'll be discussing about hard disk, guys. Okay, yes. So let us meet in the next lecture. Thank you. Thanks for watching. Like, share and subscribe for more awesome videos like this. Thank you.